This video will cover the Geometry Review Day 1 packet numbers 6 through 10. If you missed the first 5 questions, go find the video that says numbers 1 through 5. Alright, we're going to get going in just a second, so flip your paper open. Number 6 here says, which figure can have the same cross-section as a sphere? So a sphere is like that basketball shape. And if we talk about a cross-section, it's like as if we are a ninja slicing through it, and I want to know what shape it is when I pull it out. When I pull that shape out. And in this case, when I pull out that shape that I just outlined in red, it is a circle. If I were another ninja and I slice through it vertically, this shape, again, would be a circle. So no matter which way I slice this sphere, I always result in a circle. So I have to decide which one of these 4 shapes in number 6 will result in a circle if I slice through it. And you can slice vertically, horizontally, or diagonally. So think about that for a second. Hopefully you see it right away because there's only one object that has a circular base, and that's choice 2. If I slice it horizontally and I were to open up the top portion of this and show you the face would be a circle, choice 2. Number 7, a shipping container in the shape of a right rectangular prism. So that's like a tissue box, but it's a shipping container, so it holds way much more than tissues. Has a length of 12, a width of 8.5, and a height of 4. The container is completely filled with contents that weigh, on average, 0.25 pounds per cubic foot. What is the weight in pounds of the contents of the container? So if we're filling this up, we're putting a bunch of objects inside of this container, filling it completely, that's called the volume. And the volume of a rectangular prism, unfortunately, is not given on the reference sheet. So you do have to memorize that formula. Rectangular prism is length times width times height. So we have 12 times 8.5 times 4. So once you type that into your calculator, you find the volume to be 408. And because this was in feet, feet, and feet, we multiplied feet times feet times feet to get feet cubed. And that's important to understand because you can see choice 2 is 408, but that's not our answer because they want the weight in pounds. So step 1 is to find the volume, step 2 is to find the weight. And to do that, we're just going to use a simple conversion. We take this sentence they gave us about the weight, 0.25 pounds, and we change it into a fraction. And you want to make sure that you put the pounds on top because that's the unit that you want. So I have pounds, and it was 0.25 pounds per means division, 1 foot cubed. And then I multiply it by another fraction. And my goal here is to cancel out the feet cubed. So if I want to be able to cancel feet cubed, then I have to have feet cubed on top. Which is great because the volume that we just calculated was in feet cubed. So we have 0.25 pounds over 1 cubic foot times 408 cubic feet over 1. No units, because if you were to put pounds down here, then you would end up canceling pounds and that would be pointless. Okay, so now feet cancel with feet, or cubed feet cancel with cubed feet, and now we have this fraction, 0.25 over 1, being multiplied by this fraction. So in your calculator, type those 2 in, multiply them, and you find out that the weight is equal to 102, which is choice 3. Taking a look at number 8, we've got this circle, we have chords, and it says which statement is not always true. So let's just mark up our picture before we do anything and just try to figure out what is true about this picture based on the chords and the angles that we see. When I look at angle E, I notice that it opens up to CF, the arc. But I also notice that angle D opens to the same exact arc. So if 2 inscribed angles open to the same arc, they must be congruent. So I know right away that angle E is congruent to angle D. I also know that angle C, an inscribed angle that opens up to arc DE, is congruent to angle F, another inscribed angle that opens up to an arc DE as well. So again, inscribed angles that open to the same arc are congruent. We also have a pair of vertical angles in here. And so now we have A with an extra A if we need it. But if we have AA, this means that the triangles are similar. If the triangles are similar, then that means that the sides are in proportion. Meaning like fraction equals fraction, and it's the corresponding sides. It's important to mention that it's the corresponding or the matching sides, because if you match up the wrong parts, then they're not in proportion with one another. So we just found out a lot about these triangles and these angles, so it should help us narrow down our choices. I can definitely cross off choice 4 because it says the triangles are similar, and we just found that out by AA, similarity. It's okay to have AAA here, by the way. It's not okay to have AAA congruence, but it is okay to have AAA similarity. If I look at choice 3, let's just go bottom up, it says CE over EG, and then FD over DG. So when I look at my picture, let me grab another color here. CE and EG are from the same triangle, so that's a good thing. FD and DG are from the same triangle, so that's another good thing. Now when I look across, I want to ask myself, does CE match with FD? And the answer is yes, because they're on the outsides of those triangles if you look at them. And then I look again across at the bottom pieces, EG and DG, and I ask myself, do they match? Do they correspond? And the answer again is yes. So I just have 4 check marks here, 1, 2, 3, and 4, which means that that's a true choice, and we're looking for a not. So that matches with the part that says corresponding sides are in proportion. The next one says angle CEG, which is here at E, is congruent to FDG, which is at D. We already said angle D is congruent to angle E, so that's gone. And the last one says CG must be congruent to FG. So here's CG right here in blue, here's FG here in blue, and I know that they could be congruent, but they're not because the corresponding sides are in proportion, not necessarily congruent. So choice 1's the answer here. Flip it, we got 2 more questions for this video. All right, number 9 is actually kind of like an old Regents question. It says, which equation represents the line that is perpendicular to the line whose equation is represented by 2x minus y equals 7? So as soon as I see the word perpendicular, I need to be thinking about the slopes. And the slopes of perpendicular lines are opposite reciprocals, meaning that they are flipped and negated. So if I have the equation 2x minus y equals 7, I first need to get it in y equals. So I need to get y by itself. I'm going to subtract away 2x from both sides. So I have negative y equals negative 2x plus 7. Then I have to get rid of this negative 1 that's technically in front of the y by dividing by negative 1. So now we have y equals positive 2x minus 7. And when we talk about slope, it's the value in front of the x, the linear term. and that's really over 1 if we want to make it a fraction, because remember, slope is rise over run. So if my slope is currently 2 over 1, I want the perpendicular slope to be the flipped and negated version of it. So I'm going to flip the fraction upside down and then negate it. If it was already negative, negating it would now make it positive. So the perpendicular slope is negative 1 over 2. So I find the choice that has negative 1 over 2 in front of the x, and it's choice 1. The next question says, which regular polygon has a minimum rotation of 45 degrees to carry the polygon onto itself? So I know that I can rotate any figure in total 360 degrees. So I'm going to start with 360, and then if I want to figure out how many sides it has, I have to divide by the 45 degree minimum. 360 divided by 45 will give me a value of 8. Now I have to decide which shape has 8 sides. Starting from the bottom, I have a pentagon, has 5, a hexagon has 6, a decagon, like a decade, has 10, and an octagon, like an octopus, has 8. Choice 1. This could also work in the reverse. You could have taken 360 and divided it by every single choice by the number of sides and seen which one comes out to be 45. So like, for example, when I divide by 10, I get 36, which is not true in what we're looking for. Check in with the next video if you want to look at some short answer 2-point questions, like that construction that you see down below.